In tonight's omarvision tutorial, I'm going to go over marching cubes again, except unlike this video here where we did marching cubes and the point between the two vertices was a halfway point, I'm going to use linear interpolation, which is going to make the mesh that's generated look much smoother. So for example here, in my example here, I have a mesh that is going to be generated, and it's the caves in Perlin 3D noise, and you're going to see here that, come on, it's going to look much smoother. Because what linear interpolation does is instead of always picking the halfway point between two vertices of a cube, it picks a point between the two vertices of a cube based on how much that cube is on or off. Okay, between the two cubes, whichever one's on more than the other, the point pulls more toward that side, and it just makes everything look smoother. So this is an example of some 3D Perlin noise, which kind of like makes like these caves and holes. And then I have another example here where it's, example one has Perlin 2D noise. Example one, play. Okay, and this is Perlin 2D noise, which is what Unity has the ability to do all by itself. And also I just had a ball here to show you that today I'm also going to show you when you make these meshes, you can put mesh colliders on them, so you could actually use them in a game. I forgot to do that in the other video, and then I saw questions about it. So those are two examples. So to show you, let's see, example 3 here. This is the one I kind of made that shows us how the whole marching cubes algorithm works. And it's a little bit more advanced interface here than I had for the previous marching cube video. So let me just run this. Let's see here, the mesh. Yeah, so here I'm just showing outline of the 3D volume of space. This shows the current marching cube, and then whatever the mesh is there based on the points, it's going to just show it here too for us, and I'll show a little code here. So in this volume of space, when I press play, there'll be a number of grid points that are made within the space. Now, as you saw in the first two example scenes, you don't have to show the grid points, but I'm just showing them here so you could see that it's from these grid points that I'm going to have something determined. Now, when I highlight a grid point, you can see that they're not just on and off. Now, black is the most on to this color here, which is the last color on that's still going to be considered inside the mesh. So the points, they're going to fade from black to white, and it's not showing the white points because those are on the other side of the surface level. Okay, so here I could control the surface level to say where the value of a point is going to be inside a mesh surface or outside. So if I just move this here, you're going to see that, I'm adding more points to the inside of the surface the closer it gets to 1. And when it's at 1, basically all points are going to be inside the surface. But as I go down, these points with their random values going from 0 to 1, less and less, whatever I say is the surface of the mesh, it changes to say what's going to come out. Now, so these are the points. Now, if I render the marching cubes and press the space bar, and this is a 2D, and then this little cube here, if I move it through the space, let's see, move forward a little. No, that's down, this way. Okay, it's not working exactly the way I wanted it to, but as you move, you can see that in this cube, there's these 3 points are on, and that's the way the surface is measured. So it's not always the 0.5. It's not always like halfway distance anymore. When it's marching cubes with linear interpolation, it's judging between the 2 points, like how much on this is and how much the values of these 2 points, and it goes closer to the, it picks a value between the two. So you see right here, this is not exactly hitting the middle. Right here, the middle would be up here, but it comes out smoother because of the linear interpolation. And I could move the, select the cube, and down here you can see this is configuration 15, and points 3, 2, 1, and 0, which are A, B, C, D are on, all the bottom points, and surfaces like this. And then right beside it, here, this is also 15. This is also 15, but you can see that the mesh ISO surfaces, they're curved because of the values. So that's what's giving a smoother look. Also here, I could change, let me select the mesh again, and I could play with the surface level, the zoom level, the point size, but here is noise 2D. Let me do it with noise 3D. So I'm going to click this here and press the space bar. Okay, click space bar, and this should be 3D noise. Let me get some more in here, and let me change the surface level So I could have some more points in here in 3D noise. The points are using a Perlin 3D, which is not part of Unity, but I kind of created a function for Perlin 3D that it's using, and it generates the mesh like this. And to render the mesh, let me press spacebar, you can see that this one's making it look like there's rocks, okay, in the scene that there's rocks. Now, I could flip it around and have it look the other way. Instead of rocks, make it look like caves by changing the order that I connect the triangles in, okay? Anyway, so this is the demonstration here. But then there's one other thing I could do with this. Let me show you example 4. Let me load up that scene. Now the scene is going to fill this volume with some points. And then I'm going to be able to move this sphere. This is going to be colliding with the points. And as it collides with the points, the value of the points will change, okay? Which is kind of like me drawing in 3D space. So let me press play. And I'll show you. Now I'll select this ball here, and maybe I'll just move into the space. And when I hold it on a spot, hey, what happened? Hold on. Oops, I forgot to add the script here. See the mesh. So mesh 4 has the mesh 4 script, okay? And the size, I'll just make it bigger. Okay, leave me alone. I'll make it bigger. I'll make it 10 by 8. No, I'll make it 5. No, make it 7. Okay, and go back by 8. All right, so there's like a space there that I could draw in. All right, so I'm gonna press play. Okay, and it'll fill the volume of space with the grid points. They're visual for us. Okay, and now let me just go to scene view so I could move this sphere. And as the sphere collides with the points over, there's a little bit of time, and the longer it's on the points, the bigger the points values get, and the mesh just kind of stretches out, okay? So this is different than when I had in the other video where it just went over and it just automatically, filled in the space. So the linear interpolation, once again, the method is smoother. So now let me show you the linear interpolation code, okay? So let me, I'll leave this here. And what we're gonna do here is look at the marching cube and the grid point. These are my two scripts that are necessary for you to use, that they're going to be on omarvision.com/tutorials page where you could download it. They'll be in the next video here next to this one. It'll be like right there. And the orange is the files, and the blue are it's the whole Unity project as a package. All right, so let's look at the marching cube script. And let me just kind of shrink it down, collapse the definitions. So this time, I did not try to figure out the configurations on my own. This time I just went to the internet and I grabbed the configurations from this website, paulbork.net. So there he had some code and I mimicked his code. Also, in my other video, I had the points as A, B, C, D, but since I'm using his arrays, this is the way we're going to think of the cubes or the cells of the grid now. So it goes A, B, C, D, or 0, 1, 2, 3. And then up here is 4, 5, 6, 7. So those are going to be the 8 vertices. But here I'm just showing the correspondence for some people that maybe got used to the letters. And then since it's not just going to be the corners, the midpoints on the edges are going to have to be figured out. These are some codes for the edges. So for the edges, we start at the bottom, edge A, B, C, and D, or 0, 1, 2, 3. Then up here we have edges E, F, G, and H. And then we go around the middle with I, J, K, L. All right, so total there's 12 edges. Okay, so the marching cube script here is this file here, marching cubes. You would take this script, you put it in your project, and this is right here. These are the marching cube tables. These are very important. This was what needed to be figured out, but I didn't figure it out. I just used the tables from that website I just showed you. I just showed you the address to this guy here. And so the edges, there's an edge table, and there's 256 values in the edge table. And here they are. These are written in hexadecimal notation and hex values when you have that 0 and an X. But each of these would translate into a number. But here they're just written in hex values. There's 256 values there that are used in this algorithm. And then to make the triangles, there's 256 values as well. But for each value, there's 16. So it's a 256 by 16 array. So here, there's 256 rows. But as you can see, when it's -1, then there is no triangle used, okay? And over here, it's saying that there's points from 0, 8, and 3 for this configuration here. So if you look at the diagram, 0, 0, hey, what's that? 0, 8, and 3, and then -1, 0, 1, and 9. And then some of them have 2 triangles, so there's 1, 2, 3, 1, 2, 3. And it goes all the way through. And, you know, it's not as easy to read as the one I wrote, but I think the one I wrote has some mistakes in it. And this one was on the internet. I think it works pretty good. So anyway, there's these 2 arrays. These are very important. Okay, don't mess with them. They're set just right. So we got the edge table and the triangle table. Now, the function you call from marching cube is the IsoFaces. And what it does is it figures out the IsoFaces for a cell in the grid. For a set of 8 points, a cell in the grid, it's going to figure out the faces that have to be drawn. So what do you pass this function when you call it in the marching cube static class? You pass it a grid cell, and you pass it the surface level. So the surface level is important, like I said, because that is going to determine, the surface level helps determine when the values are different enough to be inside the mesh or outside the mesh, okay? So the grid cell is up here. It's in my helper section, and it's a little class that has the information about one grid cell or one cube in the volume of points. So there's 8 points that make up a cell or a cube. Then there's going to be the configuration number that's being determined for that grid cell, and how many triangles are being used to create the iso surfaces to create the mesh inside that cell. And these are the edge point values and the triangle values that are pulled up. Okay, so that's what the grid cell is. The most important thing before we call IsoFaces is that we have to set the values for the 8 points of our cell before we call IsoFaces. We set them to whatever the cell is we want to look at, whatever 8 points of the grid that we want to look at. We set those points, then we call IsoFaces. Okay, so first thing we do with the cell is we just clear everything. As you see here, there are edges and triangles that were made for the configuration. We're just going to clear that. So we call it clear calculations, which just resets all the arrays back to 0. Okay, and here's a little picture of the cell just for reference. So then we set the cell's config to an initial value. We set it to 0. And then what we'll do is we'll check the value of each of the points to know if it is above or below the surface level, the point, the corner. Okay, so if a corner, here I have point 0 should be the 0 or the A. It should be this. So 0, 1, 2, 3, 4, 5, 6, 7. And that's the 4 points, the 8 points, I mean. I'm going to compare each of the points' values. These values are going to be their noise values, like basically like the color from white to black, the noise values. And if the value is below the surface level, then we're going to consider that we're going to set that bit in the config. So the bit, there's 8 corners, so there's a byte. There's 1 bit for each of the 8 corners that we're going to set. So this bits function, this bits class that I made, it just sets the bit for that corner on. Okay, so these are the bit positions from 0 to 7 to make 8. So it goes through all the values, checks to see which ones are below the surface level, and sets the point. In the end, that will make a config number. All right. So if the config number is 0, then basically it's one of these cubes here. It's one of these. Or it could be there could be a cube totally inside. There could be a cell that's totally inside. So there's no faces to draw because it's inside, or there's no faces to draw because it's outside. There's no faces to separate from, you know? So then just return. There's nothing else to do here for this cube. We're done. But if there is a config value, that means we have to figure out the values on the edges to draw the triangles. So that's what's going on over here. So we determine the interpolated edge point positions, right? For edges that need a triangle point on them, we're going to determine where along that edge do we have the point. So there's this function here called interpolate edge position, right? So if bit 0 is set, if A is a point that's on, then we're going to figure out the edge point for there. So we'll pass it A and point A and point B, the first point and the second point. This is passing the appropriate points, all right? So now each edge point, we're going to interpolate to find out where along the edge the points are on the edges, if there's a point on those edges. Then after that, we could make the triangles, because now that we know where the points are on the edges, like how far in or out the points are, now we could connect the points to make triangles. So this is what the triangle part is going to do. The triangle table is going to look up that config, and as long as it's not a -1, hey, we got something. Now you see I said as long as it's not a -1, because as I showed you in the array for triangles, here, the triangle table, see, -1s are no triangles being made, and numbers above -1 are triangles being made. So therefore, over here, I check to see if the config at that triangle table, if it's not a -1, then there's something to draw. So this is going to go every 3 points, because you need 3 points for a triangle. So I'm just going to keep adding 3, 3, 3, and then so for the first triangle, 1, 2, 3, and then I say I'm going on to the next triangle, and that's what's keeping track of which triangle I'm keeping track of. Now, this algorithm has a maximum of 5 triangles per cube, so that's another reason I think something was wrong with my marching cubes one. I had 16 triangles, so something was wrong, with mine. I had way too many triangles being drawn. That means there's a little bit too much work that's going to be done, too many faces. So this one's better, there's less, okay? All right, so let's see what happens when interpolate edge position is called. This is the part that's the hard part, is the interpolating the edge position. How do you do that? So here's the interpolate edge position function. So first we pass in the ISO level and then the 2 vertices. What is ISO level? That's the surface level, basically, like where we determine on or off. All right, so we're looking for where on the edge is the point, okay? So I can't really explain this too well. I know it's working because, to tell you the truth, I copied this. But here it looks like first it's going to see if a vertex value is like pretty much 0. If it's like this here, this approximately, math approximately, this is a math function from Unity. So when you're dealing with floats, the number may not exactly equal 0, maybe 0.00001 or something like that. So this says basically if this is equal to 0, approximately, all right, then I'm going to return vertex 1's position. It's totally on vertex 1, or it's totally on vertex 2, point 2, or over here, if the value, if you subtract the 2 values and they will come out, then you just return vertex 1. But if none of those happen, then you're going to come down here, and now it's going to calculate a position between the 2. So it calculates the point on the edge, x, y, and z value, all right, and then it returns that. So that's basically what's happening here that I could explain. And this goes pretty fast. I did like a little timer on making one cube. So I did a timer on making the whole mesh over here, and it's less than, it didn't even record a millisecond, What else can I explain? Well, here's the Perlin 3D function, which this also I got from the internet somewhere, but I just basically get all 3 permutations. If I have the 4 corners, A, B, C, A, B, C, A, B, C, 3 points, right? I get all the permutations and the reverses using Perlin 2D noise, then I add them up and divide by 6 because there's 6 permutations, and that will give me a random Perlin noise value in 3D space. That's the other thing to know. Get mesh here, this is all in the marching cube class. It's just going to, I added some stuff to this. So get mesh, it's going to, you're going to pass it in this time to game object, and it's going to add a mesh renderer and set the material that's going to render on the mesh. So here it's those stones. Then it's going to add a mesh filter if it's not there. The mesh filter has the mesh. But we have to make sure that the mesh is allocated on the mesh filter. So if we are in the application editor, like I am here, then it's going to use application is editor true. It's going to use shared mesh. If we are actually, we built the game, we did the build, and we're running the build of the game, then it will use the mesh. Index is how many vertices we could have. So I set that to a uint32 so I could have 4 billion instead of uint16, which has 65535. Then I give it a name. Now here's a new thing I added, all right? So up here, when you want to get the mesh, you could provide a boolean to say whether you want a collider or not. So if you said you wanted a collider, the get mesh function is going to it's going to try to get the mesh collider, and if it's not there, it's going to add a mesh collider. So I'm using mesh collider because we don't know what the shape of this is going to be. So mesh collider just conforms to the shape of the mesh exactly. And for the mesh collider, you're going to set the mesh collider shared mesh equal to the mesh filter mesh. After this is all done, we'll just return the mesh in case the caller wants to use it. So that's the get mesh. It's a little bit different. I changed the parameter here, and I added a parameter there. Then set mesh, it's kind of similar. I pass in the game object this time, and then I pass in the 3 arrays. So here we get the mesh filter mesh, boom, okay, when you set the mesh. Clear the mesh arrays out, then we set the mesh arrays. Then we recalculate the bounds and the normals for the light. The bounds are for, I guess, the size of it in the scene. The normals are so it could tell for each face what's the light angle on each face, each triangle. And if you were using the universal render pipeline or, the lightweight render pipeline and you made your own shaders, I think you have to call recalculate tangents, but I'm not in the scene, so I just didn't call it. Now here's the new thing I added. The mesh collider is not going to work because I just changed the mesh. So I have to say the mesh collider shared mesh equals this new mesh so that the collider works. So this was new too from my last video. All right, so this is basically the marching cube class that you're going to use. Then there's some helper stuff here. I explain the grid. The triangle is just basically 3 points. And the bits is just to help you with the bit math. So I could set a bit, in a number, I could set a particular bit on a value. Oh, I could check if it's set, okay, and that's how you could check if a bit is set. You just give it the position and the value, and it sees if a bit's set in that position. This is setting a bit and removing a bit, okay. And then it could take the number, whatever the value is, and it could translate it into like A, B, C, D. That's the binary form letters, or the binary form numbers, like 0, 1, 2, 3. Okay, and it could go up to 12 because the edge has 12. And then this is plain old binary form, zeros and ones. Okay, so that's explaining that. UV coordinates was just the easy way, like I said, to understand a flat picture. A, B, C, D. These are the four corners of the picture, and these are the values for each corner. All right, there's one thing, the grid point. This is commented out because you could either use this grid point class. As you can see here in the functions, IsoFaces and everything, in a number of places, where is it that it's used? I think it's in my grid cell. Yeah, here's the grid cell. See, I'm using grid point. So I need information for each grid point. It needs to hold the value and the position of the grid point. Those are the two things grid point needs to have. Now mine's commented out because I wrote my own grid point class right here, which has more things. Now I still have value and position, but in order for me to do this demo where you could see the points and they change colors, and then when I move the sphere and the sphere is colliding with each of the points and making the mesh grow, I have a collider and a trigger event detection. So, my grid point class is a little bit enhanced so that I have the position, the value, I have the size, I have whether the point is on or off, I have the color and glowing. Now, and then mainly over here, I have the on-trigger stay. So for interpolation, I used on-trigger stay because the longer that I have where'd the ball go? Let me do it again. The longer that the ball is in a spot, you're going to see that the grid kind of swells up. Let me press play again. So that's why it's on-trigger stay instead of on-trigger enter, which fires off once. On-trigger stay keeps firing off as long as the sphere, you see, is in that space, and it kind of swells up. And if I move faster, it stays skinny. And if I stay in a spot, it swells up until the value reaches the maximum one. So that's why I used on-trigger stay, okay? And I just had the value increase. And I use time delta time, so it's the same speed on every computer. And since this grid point has the event, I want to fire off an event, so I made my own events here for on-point value change. So I have a delegate. That's the kind of function that is going to have to handle this event. And then the event itself, on-point value change. So here, if somebody's listening to the event, on-point value change is not going to be equal to null. If somebody's listening to an event, then I just get this grid point script right here. This is the script for this point right here, and I call on-point value change, and that happens. It's going to call and go to mesh 4. Yeah. And then here in mesh 4, this is basically how I use the marching class thing. Here in here on the on-enable, I listen to the on-point value change event. It's going to call my own on-point value change here, and you see it takes a grid point. And then when the script is disabled, it removes the listener. See, so then here in the on-point value change, I could actually request, I could just change this value to request a build. And then in the update function, if request build is true, then it's going to go ahead and build the mesh. So instead of just saying on-point value change, calling build mesh here, I use a boolean as a flag so that I didn't have a bunch of builds building up on top of each other, say multiple points are firing off the on-point value change. It will just happen, one time, and then see if there's any other points that need it, and then happen again. I was just trying to manage being overloaded by build mesh calls. So that's why I separated that. So let me show you. That's the marching cubes thing. That's the grid point class right here. You need these two things, all right, if you want to make your own project. And let's go back to example 1 that I had. File, let me just save that. And let me see my scenes. Example 1 was just the terrain that went up and down, I think. Let's see. So this, I'll just show you how do you use the marching cube script, how to use that file if you want to use it in your project. So here is a smooth terrain. It has a collider, you can see, right? So this is mesh 1. So let's look at the mesh 1 script. So using the marching cube script, pretty simple. You just have to do this. 1, you need a grid of points. Okay, so I got a grid size. So you can say how big you want your volume of space to be that's going to do this marching cube thing. The zoom level, the surface level, the material you're going to render, and now the grid of points. There's an array for each of the points. All right, and it's a 3D array, X, Y, and Z. And then I have my, I'm using a list because I don't know how many vertices and triangles and UVs I'm going to have, And then I have the grid cell, which I got to pass to the IsoFaces thing. All right, so in the start, first thing is I build my grid of points. Okay, X, Y, and Z, and I just add a point in each position. And at the same time I'm adding the points at each position, I'm also going to calculate the noise value for a point. Okay, and this is a Perlin noise from Unity. It's a 2D thing, which makes the hills like that. So I calculate each of the points in the 3D space. They're evenly spaced, and I also calculate a value for them all in one swoop. That inits the grid with the noise values in it. Then second step is build a mesh based on what the points say. So first I get a mesh object. That's going to make sure I have a mesh filter. Where are you? Let's make sure I have a mesh filter, and it's going to make sure I have a mesh renderer and a mesh collider if I asked for one, and I did. See, I said true. Then I'm going to clear my my 3 lists, and then I'm going to start to build the lists. So like I said, as I go through each point in the 3D volume of space, I have to set what the grid is. What are the points, the 8 points for the current cell or cube, you know? Then I call the IsoFaces function, pass it that cell, and I say what the surface level is. Okay, so that makes the, that gets the cell, that gets the data to make the triangles in this one cell, this one cube that I marched. And then over here, I build the mesh for that one cell. Okay, so when I build the mesh for that cell, it's going to set my vertices, it's going to add to my vertices, my triangles, and my UV. Okay, now UVs, they're going to flip back and forth, you know, because you see this is like a picture that's getting rendered, but it's triangles. So the first triangle is like this half in the bottom, and then the second triangle is this half in the top. So I just keep alternating back and forth between the 2 UVs, you know, depending on if it's a odd or even triangle. And that's what this is, alternating back and forth. Now, this is important. The triangles, the order that I connect them in. All right, so say here I'm connecting the triangles by vertices 1, 2, and 3, and it's drawing the top side, right? Now, say you render this out, and by mistake you see something like this. Let me switch the order of the triangles, because the order that I connect the points for a triangle determines which side is rendered. So here, I switch them to 3, 2, 1, and I save it. And now, if I go back in Unity and I press play, it's going to look like nothing rendered, or it's kind of like weird. It doesn't show everything, and everything goes right through, because what happened is instead of rendering the top, the order that the triangles are connected in, it's rendering the bottom. Okay, so that's why the order you connect your vertices in is important. So in case you see something like that, then just turn this thing around, change the order, clockwise order. Okay, that's in case you see that problem, and then it will be better, or it'll be what I was expecting. That's better. Like this. Boom. Okay, so this code is going to be on the internet, on my website, like I said, over here on this page. You can just search Orange and Cubes. And if you have any questions, you could, you know, ping me on Facebook or a comment in YouTube. Thanks a lot, guys. Bye. You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.